Hello dear students. Yes, here in this question we are given with the rate constant expression which varies with temperature according to the equation S logarithm of rate constant K is equal to what is given, dear students? It is 5 minus 2000 divided by temperature. So this is an expression for the rate constant, of course per minute, isn't it, which varies with the temperature. So by making use of this equation we have to select the right options there. Of course the option includes statements. There are three statements given. First one about the frequency factor, the second one is about the activation energy EA, and the third one is about the verification of the linearity, whether the graph against log K versus 1 by T, okay, is linear or non-linear, so etc. Out of the given those three statements which are true is a question. Yes. So what we do is we go for the Arrhenius equation here, which is actually the variation of rate constant with the temperature, isn't it? Can be explained with the help of this particular Arrhenius equation. So what is that equation? We have Arrhenius equation as S log K is equal to, see I am writing directly logarithm form of Arrhenius equation. Log K is equal to log A minus EA divided by 2.303 into R into T. Do you agree? Basically we have a equation, Arrhenius equation, as rate constant K equal to A into e to the power minus EA by RT, isn't it? So it's exponential form. When you take log on both the sides, you'll get this equation, isn't it? Yes. So now compare equations, given data or the expression with the standard expression. So what we get is, so here, isn't it, log A is equal to 5, log of Arrhenius constant A is equal to 5. So log means base 10, isn't it? So what is A? This implies Arrhenius frequency factor A is equal to, can I write 10 to the power 5, isn't it? Anti-log of 5 is 10 raised to 5. So whatever the statement 1 which is given is right. Coming to the second one, activation energy, you compare activation energy. See, 2000 divided by T is equal to EA by 2.303 RT, isn't it? So what is 2000 EA by 2.303 into R, because 1 by T is here and as well as in the standard equation, isn't it? So what we get is also I'll write that activation energy EA divided by 2.303 into R is equal to 2000. Do you agree? Yes. What is activation energy? This implies EA is equal to S 2.303 into R into 2000. So I'll write it 2.303, okay, into 2000 into R value in calorie, because of the third statement or second statement rather says that it is in 9.212 calorie, kilocalorie. So let me write in calorie first, later we'll convert into kilo. So this is nothing but 2 calorie per mole. So when you multiply 2 into 2, 4 into 2 is 6, am I right? No, 8, and again you have 2.3 into 4 which is 9.12. So I have 9212 calorie per mole. So in terms of kilocalorie it is 9.212 kilocalorie per mole. So the second statement is also right, dear students, related to activation energy. Third one is about the linearity. So I have an equation here given in the form of y is equal to m into x plus c. So this will be minus m, that's it. So what is c? Intercept, which is log a. What about minus m? It is minus 2000, isn't it? Then x is 1 by t. So when you plot log k against 1 by t, you're supposed to get a straight line of this type, isn't it? We have seen in theory. So downward slope it will be, or downward straight line, and here you have log of k and here you have 1 by t. So this will be slope which is nothing but minus 2000. So thereby it is possible to get a linear graph with this particular expression. So all the three statements given are right, and therefore our option is supposed to be option A. Okay, so option A is a right choice for this question. That's it. Hello students, in this question we are given with the nth order reaction rate expression, isn't it? For nth order reaction rate is dx by dt, which is equal, of course, k into rate constant into a naught, which indicates initial concentration to the power some n is the order of the reaction. Fine. What is asked? A graph is given in that where variation of log of rate against log of initial concentration told with the p, q, r, s. There are 4 straight lines. Now question is which is the correct order for the particular lines. So each line represents particular order. So which one is having highest order, which one is having least order is the question. So how to conclude this particular question or complete this particular question, dear students? Very simple. Okay, I'm not drawing that graph because it is there in front of you. You can see it, right? So what I do is I'll write the expression which is given there. It is dx by dt rate, which is equal to what they told. It is equal to rate, of course, which is equal to how much? Rate constant k into concentration of A, that is at the beginning A naught, to the power some n is given. Since graph is related to log of the rate, what I'll do is I'll take log on both the sides. I'll consider this expression, okay, here underline expression, I'll take log on both the sides. This implies that log of rate, okay, is equal to n into log of concentration of A naught or concentration of A at the beginning. Are you getting, dear students? What is this? Log A into log B is log A plus log B. So I'll take A as this one, B is here. So plus what? Log K. So this is of the form y equal to mx plus c. You supposed to get a straight line, whatever we got there is correct, exactly, isn't it? Where slope is equal to what? N, which is equal to what we know, where n is a order. So why we deduce this particular relation is because as slope is more, n value is more or high, order is more. So for third order n equal to 3, slope has to be maximum, isn't it? What is slope? We know from that graph, slope is equal to dy by dx, isn't it? Or here it is dx by dt. Are you getting, dear students? So if I show the trial how it look like, if it is p, okay, of log rate versus log, what is that? I have log A naught, isn't it? Concentration of A naught. If I plot like this, dear students, see, this is the slope of the graph, isn't it? Now slope is nothing but d of r divided by dA, or I will write dx by dt, whatever given there, or generally dy by d, y scale divided by x scale it is, isn't it? So I have here this as a dy and this as a dx. So or dx by dt, you can relate this also equal to dy by dx. It's left to you which one notation you are selecting. Now anyway, see, this y scale as increases, or dx is more or dy is more, slope will be more. When it will be more? See, if I take another graph here where s is given, p, q, r, s, which is like this, almost parallel to the y-axis, x-axis. So what this will become, I'm not writing here scales and all. See here, slope, what happens to the slope? Here denominator term dy by dx is supposed to be, okay, dx is more rather than dy, isn't it? So slope will be less. So as the graph slides or as the graph tilts towards the x-axis, slope is going to reduce or decrease. As a result, the order also decreases. So now it's very clear, as the graph is almost close to y-axis, slope will be maximum, almost close to x-axis, slope is minimum. So thereby PQRS order supposed to be P is equal to 3, Q is equal to 2, R is equal to 1 and S is equal to 0. So this is supposed to be the order, and therefore option B is the right one. Okay, so conclusion is that option B is the right choice for this. Hope you got it why it is so. Slope equal to n, which is equal to order. So as the slope is more, order will be more. That's it. Dear students, here we are given with formation of nitrosyl bromide. Okay, NOBr2. NOBr is forming by the combination of nitric oxide, NO and bromine. Now for this particular chemical reaction, stepwise reactions are given. I mean to say that mechanism is told. Of course, one is a fast step, the other one is a slow step. Now it is up to us to find out the rate law. What is the correct rate law for this chemical reaction is the question. So what we do is, given reaction, let us write. So it is NO nitric oxide plus bromine giving S NOBr, balancing part is done. The mechanism, okay, let us write the mechanism there. I mean, before writing mechanism of the reaction, I'd like to tell you that in the case of multiple step reactions, which we call it as complex reactions, isn't it? What is true? Slow step is called as rate determining step. Therefore rate law is based on the slowest step. Out of two, the slow step to be considered. So what are the two steps given there? First step, which involves equilibrium, isn't it? That is NO plus Br2 giving NOBr2. So first step is NO plus Br2, okay, NOBr2 is formed. So this is the fast step they are claiming. What happens next? NOBr2 will combine with step 2. NOBr2 will combine with one more molecule of NO to form, okay, this is a single direction reaction, 2NOBr, isn't it? So this is what? So we have slow step over here. Our rate of the reaction, therefore rate is equal to rate constant K into concentration of NO into concentration of NOBr2. This is what's supposed to be. But if you observe the options, there won't be, or there is no NOBr2 term. What does it indicate? Our main equation is not containing NOBr2 because it is an intermediate, first step. So in the entire equation or the main reaction, we don't have that NOBr2. So this must be replaced. How to replace it? By considering the equilibrium reaction. So this is the first reaction they're telling, isn't it? However, but you write, what is that? Concentration of NOBr2 we have to find out. For that, equilibrium concept will apply. I'll write K dash as equilibrium constant, which is equal to what? Concentration of NOBr2 divided by product of concentration products to the reactant, concentration of NO into concentration of Br2. So our intention is to substitute for NOBr2 here. So let me take this as equation 1 and this is equation 2. So 1 and 2 imply, I'll take, okay, 1 and 2 imply, yes, I'll put NOBr2 equal to K dash into NO into Br2, isn't it? Yes, so I have rate of reaction, rate is equal to K into K dash, I will write, okay, K dash into NO square, right? NO square into NOBr is substituted by Br, isn't it? So Br2. Now this together I will take one new constant, let it be K, capital K. Okay, so therefore K into NO square into Br2, and if you observe there, which is that option, dear students? Option A, isn't it? So option A is our right choice, which is the rate law of this particular reaction. That's it. Hello students, we have general chemical reaction A giving products in this question. Okay, fine. Now it is told that the rate of this reaction is K1 into concentration of A. So we have minus, okay, I'll write here, minus d by dt of concentration of A, which is rate of that reaction, as K1 into concentration of A. So this is given. What is asked? After one natural lifetime, that means when t equal to 1 natural lifetime, for this given reaction, okay, if initial concentration is 10 molar, what will be the concentration remaining of the reactant? Okay, what is the concentration of the reactant after one natural lifetime is a question. Of course, options are given in terms of E. Okay. Now, exponential. Now, what we do is we write the options will suggest that it will be in the exponential form. So, let us find out the order of the reaction. Since rate is equal to K1 into A to the power 1, it is a first order reaction. This implies that first order reaction. Without knowing the order, it is not possible to find out, okay, concentration, because different order reaction has got different, or they have got different rate constant expressions. So it's not possible without knowing the order. So first order reaction. So that's it. Now for first order reaction, therefore, for first order reaction, what we have? Concentration of A after time t, that is natural lifetime, whatever it is, time t, is equal to concentration of A at the beginning, A naught, into exponential form I'm writing, e to the power, am I right, minus k into t. So this is what the expression for reactant concentration or exponential form of first order reaction. So all the different forms should be remembered. Differential form, integrated form, k equal to 1 by t into ln r naught by r, then the exponential form. Okay, so this is it. Now what we do is, one lifetime it's given concentration of A at the beginning is equal to 10 molar and T is equal to 1. So if you substitute, what you will get? AT is equal to A naught is 10, am I right, into e to the power of minus, okay, what I'll do is time is 1, so I'll write this a K. But none of the options in the given question or option list, you won't find any of this option. So what we do is, we'll assume now when, okay, when see this k is equal to, okay, 1 by t you can take, or k is equal to, what you do is substitute it, that is nothing but time is equal to 1 by k, one natural lifetime if I take, okay, this is I'll write it t itself. So when k is equal to 1 by t, or time is equal to 1 by k, just as our assumption, okay. So what happens then? A t is equal to 10 into e to the power of minus 1, isn't it? Because when you substitute t equal to natural lifetime, it's told 1. Let us assume that it is k equal to t equal to 1 by k, then what happens? This will become 1. So I have this is 10 divided by e, isn't it? So that is our concentration after time t, that is one natural lifetime. So which is the option to be selected, dear students? Yes, the option you have to select, which is nothing but the C. Okay, so that's it. Hello students. Here we are given with decomposition of nitrogen pentoxide. Okay, so N2O5 decomposes to give nitrogen dioxide and oxygen. Dioxin is formed. Fine. Now rate with respect to the reactant is given as 2.4 into 10 raised to minus 4. Of course, unit of rate is the constant, which is mole per liter per second. Now what will be the rate of reaction with respect to two of the products, that is dinitrogen, right, I mean nitrogen dioxide, and with respect to the S, it is oxygen. Now dear students, rate unit is either mole per liter per minute or mole per liter per second. Here it is given mole per liter per minute. Okay, so what we'll do is we write the reaction first, then in differential rate equation we'll write, okay, how reactant and product rates are connected. With that we'll find out. Okay, so what is the reaction given? N2O5, isn't it? N2O5 decomposes to give NO2, 2 moles plus half O2. So we have rate equation for this, or rate of the reaction is given by rate is equal to S with respect to reactant minus d by dt of concentration of NO2. Again I made a mistake here, N2O5, okay, N2O5 reactant I have to write first. Reactant concentration, since decreases with time, we are writing negative, whereas product will be plus 1 by 2 into d by dt of concentration of, now it is NO2, isn't it, which should be equal to plus, see 1 by 2 will become 2 times d by dt of concentration of O2. So this is a complete differential rate equation for the given reaction. What we do now, we substitute the given data. So we are asked to calculate first with respect to NO2 what is the rate, then with respect to O2. So it is asked d by dt of concentration of NO2, which is nothing but rate with respect to nitrogen dioxide equal to. So I have to calculate, this is it, isn't it? So I have to multiply this rate with the 2, isn't it? Because N2O5 is given. So this is nothing but 2 into minus d by dt of concentration of N2O5. So this entire value is given. This is nothing but 2 into, this value is 2.4 into 10 raised to minus 4. So that is nothing but 4.8 into 10 to the power minus 4 mole per liter per minute. I'll write unit here down. Okay, mole per liter, let me write as a molar, it's fine, right, per minute. So this is the first one. What about the second one? Will you find out? Okay, yes, so that is also d by dt of concentration of O2, which should be equal to, see 2 is here, when you take to the other side it will become 1 by 2, or you can write here this d by dt, isn't it, 1 by 4 into d by dt of NO2, that is also fine, but it will relate to any given thing, so which is 2.4. So this is nothing but 1 by 2 into negative of d by dt of concentration of N2O5, which is nothing but 1 by 2 into 2.4, which is 1.2, half of it, into 10 to the power of minus 4 molar per minute. So both the rates we found out, and right option, as you can see there, option D, which must be our choice over here. That's it. Dear students, this question is very straightforward one, and it is from, though calculation is a bit difficult, the question is directly asked, that is from Arrhenius equation, how temperature affects the rate constant. So what is said there, rate constant of a reaction increases 6 times when there is a 50-degree rise in temperature from the initial value. What is that? 350 to 400 Kelvin. Am I right? So when 50-degree temperature is increased, that rate gets 6 times higher than the original or initial. Fine. What is the activation energy of the reaction? So directly apply the formula. What is that? We have this formula, log K2 by K1. Ratio of two rate constant, higher to the lower, should be equal to activation energy divided by 2.303 into R into T2 minus T1 by T1 T2. Directly apply this formula. Next, substitution. So K2 is how much? 6 times it will increase, right? So K1, if you take 1, K2 will become 6. So ratio will be 6 itself. So that is log 6 is equal to, or you can write here 6 K1 divided by K1. So K1 get cancelled, 6 itself. Activation energy divided by 2.303 into 8.314. Okay, next temperature term, it is 400 minus 350 divided by 350 into 400. Yes. So what is activation energy? Activation energy EA is equal to, see, log 6 value to be known. Okay, you should know the value. You can split log 2 into 3 this and log 2 plus log 3, or if you know directly, it's easy. Log 6 value is 0.7781. So I'll write it 0.7781 into 2.303 into 8.314. Am I right? 8.314 into 350 into 400 whole divided by S. 400 minus 350 is 50. So cancel. Okay, simplify. 5 ones are 5 8s are. Am I right? Then you multiply these things and you will get the answer as 41,000. Okay, 15.5 joule per mole. Okay, and if you write it in terms of kilojoule, 41.7 kilojoule per mole. That is nothing but activation energy. Now you can clearly see the option B holds good here. Option B. That's all. Hello students, very interesting question we are having. Organic compound, that is formic acid. Okay, so thermal decomposition of formic acid follows first order kinetics with a rate constant K value, which is equal to 2.4 into 10 to the power of minus 3 per second. So rate constant K is given. Fine. What is asked, dear students? How long it will take to decompose 3/4 of the original concentration? So at what time period we will remain with 1/4 of it? In another way we can understand that question, isn't it? 3/4 has to decompose. That means how much is remaining? 1/4. Fine, no? Yes. So we will calculate this by applying an integral rate equation for the first order reaction. We have rate constant K is equal to 2.303 divided by T into log of initial concentration divided by concentration. A is a reactant, that's it. Okay, in general I am writing concentration of the reactant time T. Fine. What is asked? Time period, isn't it? T is equal to 2.303 divided by K value 2.4 into 10 to the power of minus 3 into log of A naught is, if I take 1, what is remaining? 3/4 has to decompose. So 1 minus 3 by 4, which is 1 by 4, isn't it? So remaining is 1/4. Are you getting, dear students, how it is? At what time period? 3/4 of the original will react. That means remaining is 1 minus 3 by 4, which is, yes, 1 by 4. So that is it. Now this is equal to 2.303 divided by, okay, into 10 to the power 3, let me take here, minus 3 will become plus 3 divided by 2.4 into log of 4. Log 4 is how much? 1 by 4 is log 4. Log 4 is 0.6020, isn't it? So when you multiply this, you will get 2.303 into 0.6 is 1.386. okay, so which is into 10 to the 3 is there, so 1386.4, okay, divided by 2.4. This is nothing but 5, right? 77.66 you will get. Okay, second inverse, so here it is seconds. Fine. So 578 approximately. Hope you can read this decimal after decimal point 66. Okay. So 578 second is the right option there, and the right option as a result is option A. Hope this can be solved with ease. That's it. Hello dear students. What is being claimed here is the rate of a reaction between two reactants, that is A and B, is found to be decreased by a factor 4 when concentration of B is doubled. Did you get that? When we double the concentration of one of the reactant, that is B, rate of this reaction between A and B is going to decrease by 4. What is the order of the reaction with respect to B? So let us write whatever they told in sentence, dear students. A plus B giving a product, let me consider as P. For this reaction, rate I will write equal to rate constant into concentration of some A to the power X and concentration of some B to the power Y. So this is our rate expression. Now what they told there is the rate is decreased by 4 when B is doubled. So let us consider given rate becomes R by 4, okay, when they increase the concentration of B, A to the power X, and 2 times B to the power Y. So this is what they are telling. So this implies that what I will do is I will take only proportional, okay, I am not taking that equal sign. So I can write 1 by 4 is proportional to, right, 2 to the power Y. Do you agree? because I'll take 2 to the power y and b to the power y. I'll retain that. So 1 by 4 is proportional to 2 to the power y. So what we'll write here, this is nothing but 1 by 2 to the power 2 is proportional to 2 to the power y. I'll write 1 by 2 to the power 2 as, I'll bring this to the numerator. So this will become 2 to the power minus s to the power minus 2. So this implies 2 to the power minus 2 is proportional to 2 to the power y, which clearly tells you that the order with respect to b, which we took it as y, is nothing but minus 2. Am I right? So the order of a reaction is minus 2. Order can be negative, 0, positive or fractional. All these things you know it. Therefore here is one example where order is 2. So when rate minus 2, when rate decreases upon increasing the concentration, order must be negative. This is the conclusion. So which is that option, dear students? Yes, option B. It is clear. That's all. Hi dear students, here the graph of log of equilibrium constant K equilibrium against the inverse of temperature, which is nothing but 1 by T, is plotted, which is a straight line graph with a positive slope. Please note down this particular point. Okay, the given graph is a straight line one like this, isn't it? Yes, now it is correct. So this line indicates, straight line indicates it is a positive slope. Okay, so upward, therefore it is a positive slope. It is ln of natural logarithm, ln means equilibrium constant against inverse of temperature. Fine. So gives a positive slope anyway. What is told? The nature of the reaction is whether it is exothermic or change in enthalpy, endothermic, etc., etc. So when you look into this variable, that is ln of equilibrium constant and 1 by T, one point you have to understand, or one thing has to come to your mind, is it is Van't Hoff equation. Okay, so relationship between equilibrium constant 1 by T, okay, with respect to enthalpy or the entropy, etc., is studied with the help of Van't Hoff equation. What is Van't Hoff equation? Van't Hoff equation. Okay, of equation. Please remember this equation. It's important. It actually comes in thermodynamics. Okay, what is that equation, dear students? The equation which says that ln of equilibrium, okay, is equal to minus delta H divided by R into T plus delta, of course this standard condition if you take, then delta H naught and delta S naught divided by R. So this is the expression given by Van't Hoff for the variation of equilibrium constant with respect to temperature, of course equilibrium, or the thermodynamic parameters, enthalpy and entropy is involved in this. Fine. Now if you look into this, this is of the form y equal to mx plus c, isn't it, where x is nothing but 1 by T. If you observe here, this is it. Okay, 1 by T. So inverse of temperature and ln K equilibrium, when you plot, straight line indicates that slope is positive, isn't it? But here we have slope as negative. So this implies that, let me write, slope is equal to minus delta H naught divided by, what is that, R. Fine. So slope should be negative, but from the graph it is clear that this is greater than 0, isn't it? So therefore delta H naught should be negative. Do you agree? Because otherwise slope can't be positive. If you want to have a slope as positive, means delta H value has to be negative. So negative of negative will be positive. Therefore this implies that, okay, I'll write here, this implies that delta H naught should be equal to negative. That is exothermic reaction. Exothermic reaction. Okay, so this must be the condition. Fine. So which is that option, dear students? Yes, it is option D. Exothermic. Option D is the right choice here. That's all. Hello dear students, as you can see, the question is related to the first order reaction. What is the time, that is T 1/4 for the first order reaction if rate constant is K. So what you can understand from this? We need to calculate the time taken for 25% completion of the reaction. It's told that the concentration drops to 3/4 of it. That means 75% is remaining, isn't it? So how to calculate it? Let us go for the integrated rate equation for a first order reaction. What is that equation, dear students? Yes, for a first order reaction in rate constant K is equal to S 2.303, isn't it? 2.303 divided by time, right, into log of initial concentration. I'll take it as R0 divided by R, isn't it? Yes. Now let us substitute. It is told that T 1/4, so I'll take that as T 1/4, which is equal to 2.303 divided by rate constant K, let me put that, into log of, I'll take initial concentration as 1 molar it could be, okay? So initially it is 1, so reduces to 3/4 of it. That means 25% completes. What we are writing here is what is remaining one. So if 25% completes, remaining is 75%, so that is denoted as 3/4, isn't it? Yes. So now simplify this. This is nothing but 2.303. Since we are not having the value of K, it's not required to substitute. Let me keep it as K itself, isn't it? Log of S, this will become 4/3. Am I right? Yes. So I'll write this as 2.303 divided by K into, you see, log A by B is log A minus log B. So log 4 minus log 3. Log 4 value is 0.6020. Am I right? Minus log 3 value is 0.4771. My dear students, you should remember log values from log 1 to log 10 in order to do good or best in any competitive examination. Okay, so that it has to come spontaneously. Fine. So it is log 0.6020 minus 0.477. What is the difference? It's 0.1249, isn't it? 1249. So I'll multiply it 2.303. This I'm writing 0.1249 or 125 approximately into 2.303 is nothing but 0.29. Okay, you take it as 0.12 or 12 into 224, so 0.29 times divided by K, which is my time required, which is asked to calculate, isn't it? So what is then the option, dear students? Isn't it option C? Yes, you are right. Yes, that's it.